Hello everyone, welcome to this video. Today I am going to talk with you about Java collection framework. In this video, I am not going to deep further. This is an introductory blog. Let's get started. So, what is the Java collection? Collection is a single entity which represents a group of individual objects. So, what collections offer? In array, we cannot increase or decrease the size of an array, but in collection, we can increase or decrease the size. And every collection class is based on some standard data structures. For example, linked list, set, hash table, queue, etc. So we can get many ready-made methods using those data structures. We can also get some data structure variations we do not need to implement by our own. This is great for time saving, I think, because uh, Java is not meant for uh, uh, programming. This is meant for development. This is a time saving concept, I think. Now, what is collection framework? Collection framework provides several interfaces and classes which help us with some special features of Java collection. We- Now, take a point. We already have array in Java, right? So why we need another concept like collection? There are several points I have noted. Arrays are fixed in size. We cannot increase or decrease the size of an array once we create it. So we have to assume the initial size of array while declaring it. This is not possible all of time. Sometimes we have to work blindly, I think. Java is not meant for programming, as I said earlier. It is created for development persons for purpose initially. So developers should not spend much time to implement the common data structures and algorithms. That's why collection comes to a picture. The collection framework has many ready-made data structures and algorithm implement. We have to know the key differences between the array and the collection. So we can understand why Java creators make this another concept. As I said earlier, arrays are fixed in size. It creates a slot in the memory. On the other hand, collection is growable in nature. Uh, it automatically resize its size. Memory-wise, array is not recommended. It is possible to waste a large number of memory in array. On the other hand, memory-wise, it is recommended. There is less possibility in collection to waste of memories. The array list is using array internally, even though it can resize its size automatically. So wasting a large number of memory is not possible. Performance-wise, array is recommended if you know the capacity internally, because there is no need to copy or other things. We can randomly access our items. On the other hand, performance wise, correction is not recommended. For example, there are 1 million data in array list. Now we need to add a single data. Maybe the array list need to resize its size. Now the array list will do what? It will create another new big array and copy those old 1 million data, then insert the new one. So copying all over 1 million data is a huge performance drawback. And array supports primitive and object data types both, but the collection supports only object data types. For primitives, we need wrapper types like integer type things. And in array, there is no ready-made data structure or methods, as I said earlier. But on the other hand, collection supports many ready-made data structures and methods. And array can hold only homogeneous data type objects. On the other hand, collection hold both homogeneous and heterogeneous objects. And if we want to use homogeneous in collection, we have to use generics. This is an advanced concept. We can leave this now. And what do I mean heterogeneous? Heterogeneous means in a list we can add multiple types of objects. For example, in a single list type, we can add integer, string, or maybe student type objects at a same time. Move on. And this is the whole picture of the collection interface. All of our interfaces and classes here. You can see the collection has three key interfaces. One is list and one is set, and the other one is the queue. And the list has some implementation classes, array list, linked list, and vector. Vector has another implementation or the child class, the stack, and the set has one implementation class, the hash set, and link hash set extends the hash set, and this sorted set extends the set interface, and navigable set extends sorted set. The tree set is a implementation class of navigable set. On the other hand, you can see we have a implementation class priority queue, which implements the queue interface, and another one implementation class blocking queue, which implements the queue interface. And there are other two implementation classes, priority blocking queue and linked blocking queue. And you can see there are two classes, vector and stack. They are legacy. They are introduced in 1.0 version, and majority of these interfaces and classes are introduced in 1.2 Java version. Only this navigable set and this navigable set is introduced in 1.6, and the queue, the whole queue thing is introduced in 1.5 version. Let's move on. And this is the map interface. You may wonder why map is a different. The map is different from the collection interface is seen in earlier slide. And this is a part of collection framework, but not not a match with the collection interface. And you can see this map is also a interface. There are several implementation classes: hash map, with hash map, identity hash map, linked hash map extends the hash map, and the sorted map interface. This is like a sorted set you have seen in the collection slide. Uh, Navigable map entry. I will talk with those in briefly later, but now just see those diagrams. Okay. And we have hash table properties, which hash table also extends the dictionary abstract class. This whole side, dictionary, hash table, and properties, they are legacy classes. They are introduced in Java 1.0 version. Let's move on. So there are some basic properties of the collection interface here. Yes, we have to know about these properties because those helps us to think why Java creators create this interface, and those are the collection interface is the root interface of the collection framework, although the map interface is not a part of the collection interface. This collection interface plays a vital role. The collection interface contains the most common methods which are applicable for any collection objects, and there is no concrete class that implements the collection interface directly. You have seen in the slide. Now let's move on. We now we are talking about the child interfaces in the collection interface. The first one I am going to talk is the list interface. It has some special properties. Those are, it is the child interface of collection direct. We can insert or add duplicate items in a list. The insertion order is preserved. For example, we first insert 13, then 5, then 20. Here is the insertion order is 13, 5, 20. This order is preserved in this list interface. Let's move on. Next one is set. It has some key specialties. This is also the child interface of collections like list. In set, duplicate values are not allowed. If we do, we will get exceptions. I will see you later. And in set collections, there is no way to preserve the insertion order. I will explain later why they don't preserve the insertion order. For now, just know the basics. Next, we have sorted set. It is a child interface of set, not the collection. The key differences from the set is that the insertion order is sorted order, not a random order like set. What sorting order it is used, I will explain later. Right now, just get familiar with the interfaces. Next, the navigable set. This one is the child interface of sorted set. This interface contains several methods for navigation purposes. This makes difference from sorted set. Now, let's talk about the differences between list and set. Based on our requirements, we can decide which is good for our use. Let's talk about them. In list, duplicates are allowed, and in set, duplicates are not allowed. In list, insertion order is preserved, and in set, insertion order is not preserved. In the sorted set also allows sorting order. And where we need a intact list, we should go for list. What comes first, we need this, then we go for list. And where we need only unique data, no duplicates, we should use this set. And if we need a sorting order, then we should use the sorted set. Now let's move on to queue. Queue is famous for its FIFO properties. FIFO stands for fast in, fast out. The queue is the direct child interface of collection. When we need some priority order, we should go for this interface. The usual priority order is the FIFO, the fast in, fast out, but we can also implement our own priority order for processing. Now let's move on to map. Once I thought map is a part of collection interface, then I learned this is different from the collection interface. Despite it is separate from the collection interface, it is a part of the collection framework, not interface. Just do the thing. This is framework, a part of framework. The crucial property of the map interface is the key value pair concept. We can represent a group of individual objects as key value pairs. Uh, Both key and value should be objects, not the primitive as list. If you want to use like integer, you have to use the wrapper plus integer and so on. And in map, duplicate keys are not allowed, but the values can be duplicated. Here is an example of key value pair. You can see the ID is the key, and I place name as value. You can see the ID is 1, 2, 3, and this is an entity. I will talk this in explain later. That now see the example. And as I said in this point, I cannot use duplicates here, the ID column, but obviously this value, the name column, can be duplicate. Now let's talk about child interfaces of the map interface. First one is the sorted map. This is the child interface of map, direct child. The key objects are maintained using some sorting order while insertion. On the other hand, value objects have no restriction. They are not maintaining any sorting or any other order. And there is another one, navigable map. This is the child interface of sorted map, like navigable map. Like navigable set. This contains some methods for navigation purposes. Now, there are several utility classes and interfaces to enhance the Java collection. There we can define the sorting order in a collection. There are two interfaces here. One is comparable and another one is comparator. If we want natural ascending sorting order, we should go for this comparable. And if we need custom sorting order, then we should implement this comparator interface. I will talk to you later. Just keep in mind those are for sorting orders. And we also have cursors in collection framework. This is used for traversing a collection. After Java 8, in Java 8 actually, we can also use the stream like a functional coding style. But I think we need to learn those things. One is enumeration, and this is a legacy one, and another one is iterator. It is start to end, I think, and the list iterator, it is interface. We can go backward from or the previous one using this cursor, and we have other utility classes like collections and arrays. These are used for some utility things like sorting, searching, etc. In Java, there are searching like quick search, quick sort, and for searching, it is binary search. I will talk to you later about this in details. Uh, there are many more to talk. There are a lot to learn. The collection in Java is a vast topic. It is difficult to cover in a single video. Next, I will talk about the list and set interfaces and their implementation process. Till then, stay safe. Happy learning. Goodbye. If you like this video, please like, and if you have any feedback for me, please reply in the comment section below.